Okay, so we're going to do a little review for our upcoming quiz here, Q-1-12 on rotational motion. The quiz begins with talking about, or the review for the quiz begins with talking about a flywheel. So we'll just draw a little picture of a wheel here. It says it has a diameter of 85 centimeters, so that's kind of a trick. Really, it has a radius of half of 85, so that would be 42 and a half, and turn that into meters, and that's 0.425 meters. So that's really our radius here of our flywheel. And it's spinning at a rate of 120 RPMs. So that would be W initial, 120 RPMs. And then afterwards we have W final. So he hits the accelerator, and within a 2-second time period, he's going to step it up to 250 RPM. So the question is, what do we do? So we're after alpha, and alpha is a change in W over T. Now the units for alpha have to be radians per second squared. So true, RPMs are an example of angular velocity, but it's not really the way we want to work with it. So the first thing we want to do is turn 120 RPMs into radians per second. So it's a pretty simple process. It's just 120 times 2 pi, then we want to divide by 60. And then we're going to do the same thing. You just hit second in your calculator and do 250 times 2 pi and divide by 60. And so if you do this, you're going to end up with answers of 12.56 and 26.18. So those are our answers for the first two blanks. So now we're ready to go back and do our alpha since we have the right numbers. So since we have 12.56 and we have 26.18, we can say 26.18 minus 12.56 over the time it took to. That will tell us what alpha is. So we come up with an alpha of 6.81. So 6.81 is going to go right there. Now as soon as we have an alpha of 6.81, let's talk a little bit about what that means. So only during this short 2-second time period do we have another arrow that pops up, and that arrow is alpha. We always have an arrow here, and that's called AC or AR, centripetal radial acceleration. But when we flip that switch for 2 seconds, we get another arrow. If it's in radians per second squared, we call it alpha. Now that's not really what we want to work with here. Also, we want to work with this in meters per second squared. So we need to figure out what AT is, or tangential acceleration. So it's easy to make this trip right here. We just multiply it by the radius. And if you remember from our original drawing, the radius was 0.425. So we're going to take 6.81, and we're going to multiply by 0.425, and we're going to end up with an answer of 2.89 as our meters per second squared. So now we know what the arrow is on the outside. Now we need to find out what the radial acceleration is, or what the centripetal acceleration is. Two ways to do that. You can take v squared over r, or you can take w squared times r. And when you do that, you should come up with an answer of 291.29 meters per second squared. This is a great chance for you to check yourself and see if everything you did up to this point is right. If you get it both ways, then you know your answers for w are correct, and then you also know, like you know this was correct, and then you would also know that your meters per second were correct. It's easy to go from w to v. You just multiply by the radius, and then you could check that as well. So when you do that, you get an answer of 291.29. Oh wait, I already had that written down. So now we need to find the net. So to find the net, what we're going to do is we're going to take this object that's going in a circle and realize that most of its acceleration is here, and we got a little bit of acceleration right there. And what that means is, since these are 90 degrees of each other, we can do head to tail. So we pick up the little arrow and move it over, and we solve for the net over the overall. And so it's just simply Pythagorean theorem. So r, or the resultant, is going to be equal to the square root of 2.89 squared plus 2.91.29 squared. And when you do that, you find it doesn't change, really much at all. It went from 291.29 to 291.3. And so the bigger contributor to this acceleration is definitely just the fact that we're going in a circle. And the flip of the switch really doesn't do much at all. And that's how you do the first problem in the review. I'll put another one on here for the second problem.